Go to these last two problems. Is everybody here?
Page 96.
This is it's a little bit of a derivation on what we did yesterday. It's a little bit trickier. This is easily the most missed question on the test. It's not hard. It's just remembering one small little detail that tends to throw people. And that detail is what I'm checking you on. Okay? Will you notice this detail? So, let's just say you were given this inequality, and you can see that it's a little different than a polynomial inequality in that it is not a polynomial, it is what we call a rational function. And technically, rational functions are chapter 5, it's the next chapter. But I wanted to sneak this in here, this chapter as well, just to give you more time to let it marinate. So you tell me, if this had been an equation, what would you have done to begin solving it? Multiply by x plus 2. Sounds great. Only one small problem. If I multiply by an x plus 2 on both sides, I'm guessing you would cancel that, right? And you would get x times this. And then you would bring down the 3. And then here's our moment of truth. What are you going to write right here?
The other way. Right?
Because what we've learned about inequalities is, if I multiply
we don't know if it's
both,
negative or not.
That's right. If I multiply both sides by a positive number, then I would leave that alone. If I multiply both sides by a negative number, I would change the direction of inequality. Well, what's x plus 2?
We don't know.
You don't know. So do I change it or not?
You do one with the
You
chips.
technically could do both. But let me ask you a question. What did we do before when we were solving polynomials? Did we worry about the inequality at all? Or did we find out where it was equal or not equal and mark those points and just check? That's what we did, right? So why don't we just say, I don't know whether it's greater than or less than. There's actually going to be situations where it might be both. So I'm just going to take the equal part and bring that down. Now, if there wasn't an equal part, what are you going to bring down? A not equal part. And what you would be finding are places where it's not true. You would just put open circles there. Now, I can solve this, right? Now, we're not going to factor that. What are we going to do? No. We're going to set it equal to 0, right? Factor and solve. So I get x equals a negative 3, x equals 1, and I come down here and I put a closed circle at negative 3 and a closed at positive 1. Now I have a question. If I were to start shading right now, you with me? Is there a chance that this part in the middle gets shaded?
Yes.
And if it was, you would be saying that every value in between negative 3 and 1 would be true, right? But I can look up here right now and see that in this original problem, there's no way that negative 2 can work. Are you with me? Now, it's possible I wouldn't have shaded that, but the problem is I have got to account for that undefined spot. If I'm over here, it can't be 1. And I've got to mark those values, regardless of what happens here, as open circles. Well, now that I have my critical numbers and my undefined spots, now I'm going to start checking. And there are no patterns here, like before. Where, remember before, they would always alternate with, they were odd powers, right? Well, in this case, you've got all kinds of weird stuff. First of all, these are odd powers. So you'd say, oh, it alternates here and here, it alternates here and here. But this undefined thing throws it off. A lot of times it does alternate. But I've looked at a lot of these that don't, and it's just kind of, I don't know. I don't trust anything about rational functions as far as patterns go. And these are rational functions because of the denominator. So let's just start checking. All right, so if I check something like negative 4, what happens? Now, the problem here is I have to check this back in the original problem. So it's not a matter of being positive or negative in the original problem. Don't check it here. You got to check it here. So if I'm checking this all in the negative in the original problem, it's a matter of it being true or false. Are you with me? Whereas before it was a matter of it being true, but it was all about being negative or positive. So I'm going to have to plug a negative 4 in there. So if I'm checking the to negative 4, I'm going to get negative 4 on the left. And here I'm going to get 3 over a negative 2, so a negative 3 halves. So is negative 4 a bigger number than negative 3 halves? No, it's much further to the left. So that's not true. I am not going to shade this. And then I can check, this is a little annoying, sorry. I try to keep these separated enough to give you a whole number, but it's not always the case. So let me check negative 2.5 or negative 5 halves. Again, negative 5 halves, when I check that, it would give me negative 5 halves greater than or equal to 3 over, what's negative 5 halves plus 2?
Negative 1/2.
Negative 1/2.
0.5.
And what's 3 divided by a negative 1/2?
Negative 6.
Is negative 5 halves bigger than or equal to negative 6?
Yes.
Yes, so shade. And then checking a 0 will be easy for me, right? I plug a 0 in there, I get 0 bigger than or equal to 3 halves. Is that true? Don't shade. And then checking something like 2 is 2 bigger than or equal to 3/4.
Yes.
Yes. Guess what the biggest mistake I see on this is?
You don't check and you just shade something.
Yes, and the open circle. Those two things. They forget the open circle. And then right here, they just bring this down. They just bring that down, bring that down, bring that down. And then they get to here and they think, oh, and they forget about the open circle and they try to shade based on this. It's just not the way it works. Or even worse, they bring the inequality here. And that certainly is not going to work. Don't do that at all. You all with me? So anyway, we had it right before the video. Let's keep it right. You with me? And again, if it's not an equal sign, then you would say, oh, not equal, not equal, not equal, not equal, not equal, and these also would be open circles. Right? But that's not the case here.
And wait, never mind.
Y'all think you're with me?
Yes.
All right, let's try it one more time. And then you'll be finished with these, I guess, on your homework. But these, it's always a test question. Do what?
This is homework?
Yep. So right here, same thing. You see an inequality, it's a rational function. What would you do? So multiply by an x minus 1. Of course, it cancels there. Here, I'm going to have to FOIL it out. When all said and done, you get that. X minus 11 on the other side. What's the inequality? I just don't know. Because I don't know whether I multiply both sides by positive or negative. So if I don't know the inequality, at least I know the equal part, right? So I'm going to bring that down. I'm going to get it all over here so I can factor it. Add an 11. If it doesn't factor, by the way, on your test, then you probably made an error because I've made all these problems work so that they factor nicely. So at this point, sure enough, it does factor nicely, x plus 4, x plus 1. And I get negative 4 and negative 1. So negative 4 is a root, negative 1 is a root, or is a critical number. But what else do I know? X cannot equal positive 1. Open circle there, and this is more like what I'd probably give you on a test where you can try, I try to, where you get nice, neat whole numbers that you can check. So the check's going to be a little worse, well, maybe a tiny bit worse than before. If I check something like negative 5, I get negative 5 plus 7 is 2. Negative 5 minus 11 is negative 16 over a negative 6, which is 16 over 6, which is 8 over 3, and that is a little bit bigger than 2. All right? And then check something like negative 2, and I get positive 5 on the left, and negative 13 over,
Negative 3.
checking negative 2, right? So negative 13 over negative 3, which is 13/3, which is about 4-ish. Is 4-ish bigger than 5-ish? So don't shade. Checking 0. Super easy. 7 less than or equal to negative 11 over negative 1, which is 11. That's true. And then finally, checking something like 2 would be 9 over a -9/1. Right?
That is not true.
And that is not true. And then we haven't even written the answers down. If I was writing the solution to this, because the graph just helped me find the solution, or the graph of it. The solution would be -3 to 2, -2 open, and then, and then bracket 1 to infinity over here on the left, and over here it would be -infinity to -4 bracket, -1 to 1 parentheses. Right?
Is there like a certain person that came up with this, or was it like multiple people?
You talking about interval notation?
Yeah.
I have no idea.
We didn't do that. Did
Yeah, we
we?
did.
Yeah,
Yeah, brackets means it's colored in or closed,
Oh,
and then parentheses open.
what is the union?
U means union. It means or.
Oh,
But AP Cal normally puts commas. But union notation is more formal. I don't care. You can put commas if you want. It's like listing your answers. Your answers could be like 2 or 4 or 5 or 7 or whatever. So or. Y'all with me? Okay. Sign off. That's the